So this is the title of my presentation, using longitudinal data to assess long-term care funding arrangements. And the aims of the presentation are, first of all, just to make a few comments about the relevance, importance of having longitudinal data when assessing social care funding arrangements. Then I would like to talk a little bit about some of the work that we've done on the basis of a dynamic factor simulation model to look at. Oops, I've just turned this off. Fantastic. Hey, it's coming back. Perfect. So I'll talk a little bit about the macro simulation model that we've got here, how we've built it, which sort of data we've used, which sort of assumptions we've needed to make, what its limitations are, etc. And of course, I'll finish with some caveats, limitations, and challenges for future researchers. We should always finish our presentations, asking for further research and, if possible, further funds for research. So, in terms of the relevance of longitudinal data for the analysis of long-term care funding, this is, in a sense, is obvious. From one perspective, in terms of what do we use these models for? We use these models to look at what the demand for long-term care services will be in the future, to try to understand how many services we'll need to purchase, who's going to pay for them, etc. And therefore, in order to go into the future, we need to look back, and we need some sort of evidence about what the trends have been in terms of some key changes, for example, in terms of need, in terms of service provision, in terms of population changes, unit costs, etc. So certainly we need, at that sort of aggregate level, we need longitudinal data in order to inform our assumptions about what is likely to happen in the future and to embody those assumptions into our models. But more interestingly, I think, it's also about the nature of long-term care. Long-term care is, by definition, something that people receive on a regular basis. It's a long-term service. And actually, therefore, the cumulative effects are very important, because this is not some sort of acute intervention that you're going to have. It's going to take, 3 days. You need to measure what happens over those 3 days, and then that's it. People are going to be receiving services over a period of time, and they're going to be interacting with the system over a period of time. And critically, the nature of that interaction will vary depending on the circumstances, and those circumstances, as I'll illustrate a little bit later, can vary. And therefore, it is important to observe, and when you look at the performance of the funding system, not just to look at how that system does for particular people at one point in time, but see how that system follows people through time, and what the lifetime, as it were, effect of different funding arrangements are. And actually, this is reflected in some of the recent policy developments. The DINA proposals, which I'll talk a little bit more about later on, are actually just, in a sense, reflecting this. They're saying, we need to have funding arrangements which take into account what's happened in the past to people and how much they've had to contribute. Well, you need longitudinal data in order to understand how much such a system, how you can design such a system, and how much that system is going to cost, what sort of effects, what sort of outcomes it's going to have. Now, this is a slightly cryptic and not very cheerful title for a slide. And this is just carrying on the similar sort of theme. In England, we've got a means-tested system. That system basically will help you if you've got less than £23,000 worth of assets. And so eventually, if you live for a very long time and you've got needs for a very long time, eventually the system is going to protect you. It's going to actually pay a lot of your care. So, in the long run, we're all dead, and we're all covered by the system. But what you want is actually to understand the trajectory of people. Yeah. So you want to understand, and for that, again, you need longitudinal data. You need to have something which tells you how people move through the system, how they interact with it across their lifetime. And this is just an illustration of that in terms of what I was going to say, pretty graphic, you might disagree. It took me an hour this morning to go to work. Anyway, so just imagine Mrs. Smith, there's no Mrs. Smith here. Mrs. Smith, she's been, she's in the community, needs to go into residential care, something happens, and after this is fine, we're following her for 62 months, and the second month she goes into residential care. She's got £100,000 worth of assets. She doesn't have accessible income, and she's going to stay in residential care for 5 years. And the residential care home costs £1,500 is an average sort of residential care. Now you see that the system is actually going to be quite harsh at the beginning, because she's got more than £23,000 worth of assets. She's going to have to pay for the full cost of the care, so the £2,500 per month. That's illustrated by red there. Those are the charges. Then those assets are going to be depleting. The assets are illustrated by the blue. You see how they're depleting fast. They start at 100,000 and they quickly go down. Here, so by the 31st month, they're close to £20,000. Yeah, they're being depleted very fast because the person is responsible for 100% of it. Then, from that point on, that's the beautiful cliff edge that we've got in the means tested system in England, and therefore the system changes completely. And from that point on, the person doesn't have any accessible income, just for simplicity's sake. So the person only has to pay a proportion of her assets, 1/250th per week. Yeah? And therefore the asset depletion from then on is much more limited, and most of the care charges are paid for by the state. Now what I'm trying to illustrate there simply is that the same person is going to have a very different experience at different points in time in her life. And that if you want to understand how well that system is doing for that person, you want to understand all that path. Because the person at the end of the day is not paying almost anything of the care, but she's lost 80% of her wealth. Okay, so and of course, if you want to get to that funding side, the funding element, you have to go through a lot of. It's a complicated process, because in order to understand what people are going to end up paying, you first have to understand what their needs are, how many of those people there are, what their needs are. What sort of informal care they're going to have, what sort of demand they're likely to have first, are they going to be offered any care, if so are they going to take it, and so on. So it's a complicated system that you need to model, and you need data for, in order to build those assumptions about what's likely to happen to somebody through their life. How much are unit costs going to change? But with Rafael, we have this conversation on a yearly basis, and it's always the same sort of technique that we use, to make the assumptions. Well, it's just very difficult, and one of the conclusions of the talk is that we need more evidence. So anyway, you need to model all these things in order to really get at the modeling of the funding system. And I don't know if you'd be surprised about this, but if you look at, for example, just something which is critical to care, which is how people's needs change through time, and this is just taking 2 waves of the BHPS, the British Household Pattern Survey, and just looking at all the people, looking at their ADLs. You can define them in different ways. This is just simply an addition of the number of ADLs. There's 6, I think, in BHPS. And just group them by whether you've got no ADLs, you're green, 1 or 2 ADLs, yellow, and 3 or more. And you actually see that the transitions are not perhaps what I certainly was expecting when I first looked at this. You see that, okay, the majority of people who in wave 12, and this happens across all waves, this is just an illustration, most of those people who have no ADLs, or the people will end up without any ADLs in the next phase, but you see how, at least 22%, so almost, a quarter of people who are really dependent have no levels, have zero dependency by the next wave. And so there's a lot of instability in the patterns of care through time. Now that's important in terms of, you could wonder, well, is this simply because the data is not right? But having spoken to Carl Jagger, for example, who's a top epidemiologist looking at exactly this is the sort of thing that she expects. So big changes through time, and the question is, are you able to get the evidence in order to model these properly into your analysis? Okay. So, and at that point, I want to illustrate how we've had a go at doing this on the basis of this microsimulation model, dynamic microsimulation model. We've got to, of course, mention Jules, who most of you would know. And so in terms of its micro, it's a model that we've built in order to look at funding, but that incorporates all those assumptions that I was talking about. And it's micro in that we can look at individuals and therefore at distributions across groups of individuals in society. And it's dynamic in that we actually age people through time. Okay, so and the dynamic component is particularly important if what you want to do is to analyze funding systems which have got some sort of memory, time memory in them, like a limited liability, like, you know, you've been 3 years receiving time, therefore something will happen, or you've paid all this, therefore, you know, you need therefore some sort of dynamic component to your model. In terms of data sources, and I'm not going to describe my data half as a tenth as detailed as you did. Just basically, I'm going to say we've pooled 13 waves of the HPS in order to have a lot of cases in our analysis. We've reweighted all that sample in order to make it look as the cross section of all the people in England at the moment. Originally, we based the model on ELSA, and we will probably go back to ELSA at some point once we've got enough waves to have enough cases because the data is going to be better eventually in terms of ELSA. So, model structure. Basically, what we do is, as I was saying before, we pulled the HPS, we reweighted. It looks like the English cross-section of all the people in terms of key indicators like health, disability, population distribution, of course, age and gender. But also things like wealth, these are very important, wealth and income, and other personal characteristics, including cohabitation, for example, which is very important in terms of informal care. And then what happens is that we make some assumptions, which I'll talk about very briefly in a second, about how the system responds and how the individuals respond. And then from the model, we get some outputs about levels of utilization of services, levels of costs, both the state and the individual, and changes in personal circumstances. So, are you going to die? Are you going to have a change? What's going to happen to your disability, etc. And we get indicators as a result of unmet need and well-being at the moment. Now we're incorporating indicators of well-being. So we need to clearly impose into the model some rules about how the system works in terms of what are the eligibility criteria, what are the funding rules, the charging rules, etc. The targeting of disability benefits, attendance allowance and disability living allowance in particular, but also income support rules, etc. So we need to model all that. We then need to have assumptions about how individuals react to the funding system, because it's very important that we acknowledge the fact that different funding systems will not just change how who pays for what, but also who gets what, because people, if you ask them to pay more than they want to, will decide not to have services. I'm just going to skip that one. And so what we do is then, at the end of the year, once we've reached that stage, we transition the model. So we transition population. We just basically say, okay, so what are your chances? First of all, we decide whether you die. There's a dummy in the model that kills you at 107. You will not be older than 107 in the model. We decide whether you die, then we decide what your dependency is. Depending on that, and you will be offered or not residential care, you will take it or not. If not, you will be offered some community-based services. You might take them or not, depending on your preferences, etc. And so on and so on. Then, we do this for 20 years, or 40, or until everyone dies, if what we're looking at is lifetime, sort of. We try to calibrate our models. So all these transitions, you have to make assumptions. You have to look for longitudinal data, which will tell you how, given your characteristics, given your need, given your your family circumstances, given your wealth, you might react. Yeah? But that is quite a, by definition, is quite an unstable sort of thing. Those probabilities that there's randomness, implicit in them. So you need to calibrate the model so that it actually hits some big aggregate levels which you think it should be hitting. And so we use things like obviously projections about mortality from the ONS, about benefit uptake, information from the information center about expenditure, service use, and number of recipients of services of social care services in England. We look at different sources of income and wealth in order to triangulate our results. Okay, I'm just gonna. These are some of the assumptions, some of the key assumptions that we make. For example, at the moment, we're still making an assumption that the prevalence of disability, age and gender specific, remains constant. That is probably an optimistic assumption, in that people are, some of the latest evidence suggests that actually that might be slightly optimistic. There might be even more dependency in the future. The prevalence of disability might increase in the future. We make that the assumption that in the long run we're talking about 2% increase in unit cost, not in the short run given where we are in the economy. We have to make assumptions about wealth and income changes. We reckon that income will grow in line with unit costs. We have to make assumptions about informal care. At the moment, we're freezing those relationships. The propensity to provide informal care is assumed to remain constant. And then we have to make assumptions about disability uptake. These are just some of the aggregate consequences of those assumptions. So if you look at the distribution of our population, and you group them in terms of need, these are people with 3 or more ADLs, more or less, although these are imputed ADLs, so they're slightly different sort of currency. But you see how mortality clearly is driven by amongst other things, disability. This is something that is absolutely critical to the cost of many funding systems, such as the Gilman proposal, which is the survival of people in residential care. This graph illustrates what the survival of residents is censored in 20 years. We estimated this on the basis of BUPA data. We ran some survival analysis models, some models on cross regressions, and it suggests that the median length of stay in residential care is just over 1 year, median. Of course, this varies by gender and other factors, and that by just above 2 years is the average survival in residential care. And this is very important because residential care is what really will grab at your assets, because it's £30,000 per year. Okay, these are just some aggregate outputs from the model in terms of numbers of people by levels of need. You'll see that overall, the majority of of all the people do not have ADLs at any given point in time. You see that the growth in actually the proportion of people with high needs is projected to slightly rise, and as I was saying before, it's likely to rise even further because our assumptions are probably conservative in terms of this. This is in terms of, that was need, that was numbers of people with levels of need. This is in terms of expenditure, breaking down by private expenditure, the red bit, attendance allowance, disability living allowance, the disability benefits, and then personal social services care expenditure for all the people. These are slightly old estimates, but they haven't varied much from the latest assumptions. And so you see that the state, for example, would spend from 6 billion to 12 billion, double in that period, more or less. You see how private expenditure will grow more if you don't change the funding system, because more and more people who are homeowners will be excluded by the current means test, for example. So that's quite useful from an aggregate point of view, but of course what is very important as well is to look at the individual. And so you can look at, for example, the lifetime. I don't know whether this surprises you or not, but if you manage to get a model like this, then you can get an estimate of the lifetime expenditure, social care expenditure. Depending on what assumptions you make about the growth in unit cost. But if you take the top table there, and if you include care and hotel costs, so the costs related to the accommodation in residential care, we estimate that on average we're talking about £50,000 on average per person, for all the person, everyone on average 50,000. I mean, it's pretty high. It might be much higher for women. No comment. You can then get a distribution of lifetime expenditure. Okay, so you can say, so if you take the cross section of 65-year-olds today, how much have I got? Another 5 minutes? Yeah. 4. I shouldn't have asked. I had 5 before I asked. So you can actually look at the distribution. You can say, okay, so if we look at the cross-section of 65-year-olds today and we age them until they die and we count how much care needs they're going to have and the value of that, well, this is the sort of distribution you get. What does that mean? That there's about a quarter of people who will not use social care services. Then there's a small minority, about 10%, who will need more than £100,000 worth of care. Now, that might be seen as unfair, because why, you're unlucky, you're in that side of the distribution, and then you're faced with £100,000 or more of care costs. That might disincentivize people to save. There's no way of insuring ourselves privately, so the state should step in. Well, that's the sort of Vilna Commission's argument. I'm just going to skip that. The model will give you all sorts of outcomes. But I just wanted to then link those sorts of results to the Vilna proposals. Andrew Dillner was asked to look at how to come up with a partnership, asking individuals to contribute. I think that's the way I read it. In such a way that you end up with a system that protects people against those catastrophic costs. But in order to do that, you need information about what the likely distribution of those catastrophic costs is. And therefore, you need longitudinal data to understand what the pattern of utilization and pattern of charges will be. He therefore came up with this recommendation for a cap, so that people will have to contribute £35,000 worth of care costs, but from that point, the state will pick up the tab. Of course, you still have to pay £10,000 per year of hotel costs if you're in residential care, because those are accommodation-related costs and not care-related costs. And so basically, that was the state will pick up, will make sure that anything above here, those 35,000, will be looked after. It won't be your responsibility anymore. The proposals themselves, when you aggregate that up, then how much does it cost? Are not that expensive. They're less than £2 billion in 2010 if they were to be implemented today, which in the context of £400 billion worth of public expenditure is not that huge for a big reform. And growing to 3.6 billion by 2025-26. And however, most of that money would be then concentrated on higher income groups. This graph is just looking at the pale blue is current expenditure, the darker blue is the additional expenditure, and that's grouped by income quintile. And you see how most of the additional expenditure will be concentrated on people with high incomes. It's not surprising, it's the people who are not served at the moment and who are therefore at higher risk of catastrophic expenditures. Just going to skip this, given that I've got now 3 minutes. Okay, so this is my last slide, actually. I'll just take 1 minute. Having illustrated all these results and exciting, I think, analysis, you're half asleep, but we'll play it. It is also important to illustrate some of the caveats. Clearly, there is huge uncertainty surrounding many of the assumptions that we've made. Assumptions about prevalence of disability, we don't know really what's going to happen, and this is hugely important in terms of even population, which is the simplest assumptions, sort of things you can look at. We systematically get it wrong. We underpredict increases in life expectancy. So unit costs, we don't know what's going to happen to them. And therefore, we have to take a pinch of salt, the results that, with a pinch of salt, the results that come out of these models. And I think we have to find better ways of illustrating that uncertainty. I think these models are much stronger in terms of comparing two systems rather than telling you what is likely to happen in 20 years' time in terms of the current system. How much would you need to spend? Because the uncertainty around every single one of these assumptions is so significant. If they were to ask me, I would say, don't believe anything. If there is any difference between two models which is less than £500 million, just ignore that. It's not significantly different. You can buy lots of things with £500 million, but these models can't really tell you. Anyway, so and we need a lot more evidence, I think, about in order to populate these assumptions. So we need more research and obviously funds for it. Thank you very much. Thank you.